Hello and welcome to my Computer Science A-Level NEA coursework. This is the first screen you are greeted with. It has 3 buttons. On the left we have the algorithm is explained, sorting window and access database. The first button is the algorithm explained. It takes you to this window with all the algorithms tabs at the top, and it tells you what is the algorithm, how it works, with a clear demonstration running through of passes and what they would do and how it gets to the final sorted algorithm. Time complexity is on the right, which is very important to understand how well the algorithm is for certain resolutions, the worst case, and what can be done to improve the algorithm, which in this case is bubble sort. Of course, exit the program down here. The next page is the sorting window. Here you are greeted with your control panel, which is the main place of the program, and behind us is the sorting screen. To choose your image, you have these 2 bright blue buttons to indicate they're first to be chosen. You can either choose your image from your computer, and you have these instructions to tell you what to do. You are greeted with your file explorer, and you simply go in and choose your image. Let's say 40 by 40 PNG, open. It will tell you the file location just to check that it's correct. Press continue and it's here in our screen. And we can zoom in, zoom out of the image. We can zoom in, zoom out because if I randomize it, it's quite hard to see, so we can zoom in, zoom out. What I can also do is group the pixels together. This is in case that the image is very large, let's say an HD image, and we need to decrease the time it will take to sort it, because otherwise a HD image is 2,073,600 pixels, and that is a lot of pixels to sort. Anyway, to group these together you simply put in 10, and the image will have 10 pixels grouped together as seen here. It does it vertically, and let's say want to sort it using an insertion sort, which will click it. An insertion sort which starts from the second item and pulls all the items to the correct place depending on it, will complete the sort. Took 8.436 seconds and we can upload to our database. Next, if we want a different image, we can click random image and we can traverse through these random images selected by the program. Let's choose this one. This is a slightly smaller image of 32 by 32, which is 1024 pixels. Let's group it by slightly less this time, 5 pixels grouped together, and choose shell sort. And now it is done. That took 35.72 seconds. That's quite a slow sorting algorithm. What we can now do is upload this to our database, and we can also zoom in, zoom out, and now view the database. As we can see, the 2 previous sorts we did, algorithm 1, insertion sort, which we did take 8.43 seconds, and it was grouped together by 10 pixels. The resolution was 1600, and the run ID is 7. These are some previous sorts I've done. Here is the one we just did, resolution 1024, grouped together 5 pixels, took 35 seconds to shell. Now what we can do is we can have this same image. Let's say we choose selection sort, increase it to 50 pixels grouped together, sort it, and start sorting, and that will only take 0.4 seconds. Now we can upload this to our database, view database. You can see that it's been appended to the database. Now what we can do is upload the records for our database, and we can now see that the maximum time taken was 35.722 seconds with the shell sort we just did, and the fastest is radix sort of 0.0837 seconds. And we can view the database to verify this. We shall look for resolutions of 1024. Here it is, algorithm ID 7 radix sort 0.0837. To verify that all the sorting algorithms work, I shall now sort an image with all of them. I shall choose a high amount of pixels grouped together for bubble, as it is quite a slow algorithm. And I shall do the rest with 30. Cocktail notably goes back and forth between the array, whereas bubble will go from left to right, then back to left to right. However, bubble and cocktail both use the same method. And now to sort is 15.48 seconds. Quite a quick sorting algorithm, so we can reduce the pixel size. And look at that, already sorted. Selection, again, quite fast. Sorted. Now you can see that selection and quick are much faster, even when they're grouping together. They're sorting more pixels than bubble and cocktail. You could tell this by the time complexity that they have. Radix sort is the fastest sorting algorithm by far. I don't even need to put the pixels together, randomize it, so this is 1 pixel each. Start sorting, instantly done, 0.1 seconds. Radix sort is the fastest. Bucket sort, a mediumly quick sorting algorithm, group by 20, and 1.38 seconds. I think bucket sort's one of the best one to look at. And last but not least, heap sort, put it to 15. Heap uses binary trees to sort the algorithm. And this will be our final sort for today. And you can tell because it slowly goes from the root element, which is the highest, all the way down to the bottom. Now we are back at the original screen, and we can access the database which we've been using to view all these records and show updates if we want to view any new ones. Thank you for watching.